Welcome to a screencast on dimensional analysis and conversions. What do we do if we're given a physical quantity, some measurement along with its units, but it's not in the quote-unquote right units? It's not in the units that we would like it to be in. Well, in order to deal with this, we convert the physical quantity we have into a physical quantity in the units we would like via something called dimensional analysis, or via the use of unit conversion factors, and it's sometimes called the factor label method. And what we do in this is we start with the initial quantity, the value we have, and then we multiply by one or more what are called unit conversion factors, and this is going to be a factor which is equal to 1, where the top and the bottom of the fraction are the same value but in different units. So for example, 3 feet is equal to 1 yard, so a unit conversion factor might be 3 feet over 1 yard, or it could of course be 1 yard over 3 feet. And possibly one conversion factor is enough. Maybe we need to do several conversion factors, and we convert by multiplying by 1, which doesn't change the value, but by using a fraction with different units on the top and bottom of the fraction, and we keep going until we get a quantity in the units that we would like, in our desired units. And usually this is easiest to see via some examples. So first example, the summit of Mount Ventoux, which is a mountain in central France. It's kind of this big mountain that sticks out of the plains, and it's often used in bike races, including the Tour de France. Since this is in Europe, the summit's height or elevation is given in meters, 1,912 meters. What is this in feet? That's the conversion we'd like to do. Well, to do any kind of conversion, we start with the known value, 1,912 meters. And now we're going to want a conversion factor that converts from meters into feet. It's possible we come up with a conversion factor that does that directly, but the conversion factors listed here don't have a meters directly to feet conversion, but we do have a meters to yards conversion, so let's start with that. And we're going to multiply by 1 meter on the bottom or denominator of our fraction, and 1.0936 yards in the numerator on the top of our fraction. Notice this is equal to 1 because 1.0936 yards is the same as 1 meter. We put meters on the bottom of our conversion factor because when we do the multiplication, meters in the 1912 and meters in the denominator of our conversion factor will cancel. And if we had wanted the height of the summit of Mount Ventoux in yards, we would actually just multiply 1912 by 1.0936 and we'd be done. But we want it in feet, so now we have to do another conversion factor to convert from yards into feet. And of course, you should know that 1 yard is the same as 3 feet. So there's our conversion factor, putting yards in the denominator to cancel out the yards in the numerator of the previous calculation. So yards cancel. And now we're going to multiply 1912 by 1.0936 and then by 3. And we get 6,273. And notice all our units except feet canceled, and feet was what we wanted, so we're done. All right, let's try one more conversion example. And cheetahs, you might know, are very, very fast, fastest land animal. And recent studies has slightly reevaluated the top speed of cheetahs, made somewhat more accurate measurements. And this study indicates that cheetah's top speed is around 27 meters per second. Okay, now that's fast, but maybe if it's in miles per hour, that would make it a little more relatable for us. So let's determine the cheetah's top speed in miles per hour. Well, we start with our known value, and notice this actually is itself a fraction. 27 meters per second is the same as 27 meters over 1 second. And we have two different units we're going to have to convert because meters is a distance and we'd like to turn it into miles. And seconds is a time. We'd like to convert that into hours. And so we can pick either one of them to do first and then the other one second. And I'm going to start with converting meters into miles. And a different conversion factor than the one used in the previous problem is that 1 mile is equal to 1,609 meters. So I'm using that conversion factor just to note there's different conversion factors you can look up, and if you use them correctly, you'll still end up with the same answer, whichever particular values you use. And this allows us to convert meters into miles. Notice, of course, meters here in the bottom of this fraction to cancel meters in the top of our original value. Now that will give us miles, but we want seconds to convert into hours. And of course, you know there's 60 seconds in a minute, so that can convert seconds into minutes. And we put seconds in the numerator of this fraction to cancel with seconds in the denominator of our original number. So seconds cancel. And then to get from minutes into hours, we do that same basic idea. Of course, there's 60 minutes in 1 hour. This converts minutes into hours. And notice after when we set this up, that miles has not canceled and per hour, hours in the denominator, has not canceled. So if we simply do the math, multiply and divide these numbers as shown, then the answer we get will be in miles per hour, which is what we want. So we take 27, divide by 1,609, take that answer, multiply by 60, take that answer and multiply by 60 again, and that turns out to be 60.4, etc. Miles per hour. And this should be rounded off to only two significant figures because we were only given our initial value of 27 as two significant figures. And notice that this 0 here is in fact significant, and we could write this as 6.0 times 10 to the first to clarify that this 0 is in fact a significant figure, not just a placeholder. Okay, so that's the basic idea on how to do conversions. Of course, one can have easier ones and harder conversions, but the basic idea is always the same. Start with the number or value you have, and then find conversion factor or factors that will convert from the units you have into the units you want. It may require several factors, but you just keep going until you eventually grind your way to the answer that you want. So that is it for kind of an introduction to dimensional analysis and conversions.